Hello class, my name is Parth and today we'll be discussing a chapter called the surface tension. Now, in the very first module of the chapter, we'll be starting with the introduction of the chapter. Now, to start with the introduction, I would like you all to have a look at the picture which is shown on the screen. Now class, if you observe carefully, we have a water spider which is resting, or I can say that floating on the surface of water. Now class, if you observe carefully, wherever the feet of the water spider are in the contact with water surface, we see that there are small dents or the depression formed. Now class, can I say that the moment the mosquito or the water spider will walk away, the dents will be removed? Again, wherever it is in contact with the water surface, the dents will be formed. The moment it flies off, the dents will be removed. So can I say that if this is the water surface, there are dents formed, and the moment it flies away, the dents are removed. Wherever it touches again, the dents are formed. Moreover, I can say that wherever the water spider goes, it can float. So I can say that the water surface is behaving like a mat, or I can say that a membrane for the water spider. So I say that for the water spider, the water surface is behaving like a stretched thing, and it is behaving like as if it is walking on a membrane. Now class, if something is behaving elastically, so I say that it has to be stretched. Just imagine you have a rubber sheet. The moment you stretch the rubber sheet from both the sides, and if you keep something on it, the dents will be formed. The moment you pick out that thing again, the dents will be removed. So this way, I can say that the water surface is behaving like a stretched elastic membrane. So moving to the next diagram, I say that if you talk about the needle which is kept on the water surface, again I say that if you observe carefully, wherever the needle is in contact with the water, there are small dents or the depression formed. So again I say that the moment you take that needle out, the depressions or the dents will be removed. Again you keep the needle, there will be dents or the depressions formed, and it will keep on happening. So I say that the water is behaving like an elastic thing. Moreover, wherever you keep the needle will be able to float. So I can say that the water surface will be acting like a membrane. And again, if it is behaving elastically, it has to be stretched. So to conclude the first and the second picture, I say that the liquid surface always behaves like a stretched elastic membrane. Why elastic? Because the dents are formed, and the moment you remove the object, the dents are removed. Why membrane? Because you can keep the object wherever you want. The water surface acts like a mat. And why it is stretched? Because in order to give the property of elasticity, it has to be stretched. So I say that water is behaving like a stretched elastic membrane, or rather I can say that any liquid behaves like a stretched elastic membrane. Now to move forward, I say that the water which is coming out of the tap, what is the shape of that water class? Yes, I say that the drop which is coming out of the tap has spherical shape. Now ever wondered why the drop has only spherical shape? Why not cubical? Why not any random shape, say pyramid? Yes, the reason is for a given volume, sphere has the least surface area. So I can say that the liquid tries to attain the minimum surface area. Remember one thing, for a given volume, the sphere has the least surface area. That is, the liquid tries to attain the minimum surface area. Okay, now if you look at this diagram, I have few mercury drops kept on a table. Again, if you observe, what is the shape of that mercury? Yes, I say that the mercury drops are spherical in shape. So I say that for a given volume, sphere has the least surface area, and hence the mercury is also trying to attain the least surface area, and in order to attain the least surface area, the mercury has taken the spherical shape. Now to conclude all the four diagrams, I say that from the very first two diagrams, I can say that it is trying to attain the minimum surface area. Now let us try to conclude all the four diagrams. So I say that from the first two diagrams, we have a clear picture that the liquid acts as a stretched elastic membrane, and from the last two diagrams, we can say that it is always trying to attain the least surface area. So class, if we were to write the definition of surface tension, I can say that the property of liquid by virtue of which it always tries to attain minimum surface area, and its surface behaves like a stretched elastic membrane, is called as surface tension. Okay, let me repeat the definition one more time. I say that the property of liquid by virtue of which it tries to attain the least or the minimum surface area and its surface behaves like a stretched elastic membrane is called as surface tension. See you in the next module class. Thank you.